Assessment of water resources. The availability of water is the basic prerequisite for agriculture and farming systems. The availability of all other natural resources is less location-dependent and, in the case of soil, even replaceable. The possible uses, however, depend on the quality and temporal availability of water. Suitable drinking water for humans and animals places the highest demands on water quality. In agricultural operations, the use of polluted water in crop cultivation does not necessarily lead to disadvantages. In the household, water of lower quality can, for example, be used for cleaning, washing, and flushing toilets. Animals and humans rely on a constant drinking water supply. The use of water in crop cultivation does not necessarily require a continuous supply of water that goes beyond the soil water content. The water demand in the household, apart from the drinking water demand, also does not require a continuous water supply. Accordingly, water quality and temporal availability also determine the possible competition for water between the components of a farming system. Factors that influence decisions on water also include the disposal of water after use. This concerns both the disposal of wastewater and the effects of evapotranspiration. Wastewater disposal can have health consequences. Evapotranspiration promotes soil salinization, which may require additional amounts of water to prevent. In addition to the available water sources, water supply always depends on the resources of labor and financial means. Labor is especially important when water transport does not take place through pipeline networks. Financial means are almost always required. An exception can be the physical transport by members of the farming system. The most important classification characteristics of the resource water are water quality and temporal availability. The requirements for water differ in the subareas of a farming system. Crop production, livestock production, and household chores have different requirements. The knowledge of chemical and biological contamination is less relevant for farmers' decisions than the perceived suitability for use. This perception can vary greatly between farming systems and regions. Household needs and animal production rely on a constant supply of water. For plant production, a daily water supply is not necessarily required, but the water needs must be met during the relevant periods. The temporal availability depends both on the delivery of natural water sources and on the rights to withdraw water. The same two criteria can be used to classify the disposal of water after use. The quality of disposal determines the possible downstream effects on the performance parameters of a farming system. The temporal availability determines the type and timing of the costs incurred. Water supply can be measured in cubic meters or liters per unit of time. However, measuring devices are not always available. Water meters cost money and are mainly present when external water providers charge for water consumption. If no water meters are available, measurement according to ordinal criteria forms the basis for decisions in farming systems. The assessment of whether the water supply is sufficient or scarce is based on experience from previous periods. The same applies to the measurement of water quality. The use of water is primarily determined by its availability. Explicit measurements of the suitability of water for specific uses are rare in farming systems and usually only take place when water quality leads to measurable problems. The translation of subjective assessments into quantitative units is associated with high uncertainties. International standards have been established for the necessary water requirements of humans, animals, and plants. The same applies to limits of water pollution for different uses. However, in water-scarce regions, many farming systems and the people living in them live with less water. The use of lower-quality water takes place wherever no other water is available. Particularly in industrialized countries, buying and selling prices are available for the monetary valuation of water. However, these market prices reflect the marginal value of water when used by all possible water users. Accordingly, the use of the market value for the specific valuation of water in farming systems is more than questionable. Agricultural activities usually require significantly more water for comparable value creation than other economic sectors. The correspondingly lower marginal value leads, from a macroeconomic perspective, to a low competitiveness of agriculture for scarce water resources. This macroeconomic perspective contrasts with the water requirements of a farming system. For the decision-makers of a farming system, the marginal value of water in their own use is decisive. This value determines the distribution of water between the components of the farming system. Decisions about the distribution of water within a farming system are, however, limited to the quantities that exceed the critical needs of the individual components of the system. These marginal values also contribute to decisions on the purchase of additional water or the sale of own water, if markets for water exist. However, other factors also play a role in this decision. This includes the essential water for continuing farming activities and the alternative uses of the other farm resources.